Looking at CPU reviews like this can be overwhelming, especially when you're looking at the newest CPU review and which CPU should you actually buy, and maybe that one's not in your price range, and there's so many CPUs and so many games tested, and then wait, there's games, but then there's also productivity tests and synthetic benchmarks, and the chips that are doing pretty well at a pretty good price point for gaming, like maybe Ryzen 5 7600X, reaching almost 96% of the performance of the flagship new 9950X in gaming. But wait, you look at productivity applications, and now the 7600X is falling way down to about 62% of the performance. What's going on there? All of that. I get that choosing a CPU can be really confusing, especially right now where we have Intel 13th and 14th gen chips having stability issues. There's a new microcode out there, but do we really know what that's done? And the reviews for the new 9000 series from AMD also very lackluster, especially when you're looking at the gaming side of things. And so I've been getting comments on my best GPU device videos asking me to do one for CPU, because I think a lot of people are feeling a little bit lost right now on what is the best CPU to buy. Well, I think that can depend on a variety of factors. As I hinted in the beginning of this video, there is a big difference between gaming and productivity workloads when it comes to which is the best CPU to buy. Now, my video is definitely going to lean more towards the gaming side of things, but I will address this split a little bit right here. So when we look at these lists for gaming versus productivity, by the way, I'm going to be using Tech PowerUp's review database here because it has a whole bunch of CPUs in it, and these were all, and this was fresh information for the new 9000 series launches. And I like how they lay out the chart with these percentages. I'm not using my own testing for CPUs the way I do for GPUs because, quite frankly, I'm not actually a CPU reviewer. I don't run these tests myself, so I am having to rely on other people's performance information to then give my opinion on buying information. Anyway, so I'll link the Tech PowerUp review here in the video description if you want to take a look at that. And anyway, so what's going on with this gaming versus productivity workloads? So let's clarify some of this. One of the big differences is that in productivity applications like we're seeing here, and this is also the case in a lot of synthetic benchmarks, having more cores generally increases performance because in a lot of productivity workloads, you can just split up the task between all of the cores and it basically scales perfectly. Where the more cores you have, the more you can split up the task. Each core does a little bit of the job, and so the more ways you can divide it, the better. Whereas in video games, that generally doesn't work like that. While some of the things a video game can do can be split off into multiple cores, they do all end up having to be put back together, usually into like a primary thread. And the splitting things off and then putting them back together ends up sometimes kind of losing some of the benefit of splitting it off. This is really getting more into the weeds than it needs to, other than, let's just put it this way. Generally, in video games, having more cores past a certain point is not particularly beneficial. So oftentimes 6 core parts actually do great. 8 core parts are generally plenty. And scaling past, 8 core 16 thread processors generally doesn't really do anything for you from boosting your gaming performance in the vast majority of video games. So that's why if you're buying a productivity CPU, you might want to get one of these big, 16-core 32-thread processors if the particular applications you use are heavily multi-threaded and scale really well with that. Whereas in gaming CPUs, oftentimes getting a 6 or 8 core part is plenty, and there's actually not really any additional gaming performance to be had from those extra cores. Also, you'll notice in gaming tests that AMD's chips that end with this X3D at the end are oftentimes near the top of the charts or outperforming their counterparts significantly compared to when we look at productivity application tests where generally those X3D parts are falling much further down the list. So what's up with that? The X3D parts from AMD are really designed for gaming because the games oftentimes, not every game, but many games, significantly benefit from having a larger cache size. So those X3D parts are stacking additional cache, which helps them a lot in certain workloads like gaming, but oftentimes doesn't really help in these big, heavily multi-threaded productivity workloads. Also, the X3D parts generally have to clock speed a little bit down in order to not overheat the 3D V cache. I'm oversimplifying a lot of this, but it gets the basic idea across, which is why something like a 7950 X3D in productivity will slightly underperform a chip like the 7950X that doesn't have that extra V cache, but can generally just clock those cores with the extra cache a bit higher. Whereas if we look at the gaming tests, we generally see the 7950X3D, notice that it is outperforming the 7950X that doesn't have that X3D cache on it, right? So the idea here is there's definitely actually a split in which CPUs make the most sense for gaming versus productivity. So with that in mind, I'm going to go ahead and say that if you want the best gaming CPU right now, and you're not really concerned about saving a whole bunch of money in your budget or anything like that, in other words, you just want to buy the best and make sure you're getting the best gaming CPU, it is still the 7800X3D that is topping almost every reviewer's gaming benchmarks. Sometimes the 14900K coming in pretty close and in certain games winning. However, the 14900K from Intel right now, I'm not going to recommend for a variety of reasons. Number one, is comparing pricing, and number two is the stability issues I mentioned with Intel's 13th and 14th gen chips. The new microcode that supposedly should stop those chips from degrading in the future hasn't been out very long, and so we don't yet have evidence that it has actually solved that problem. But again, if we just look at pricing, if I wanted to get a 7800X3D right now, to get basically the best gaming performance on the market, PC Part Picker is showing it as low as $308. However, I do have a comment on that. I actually followed that link because that seemed a bit too good of a deal. And I followed it to Amazon here, and this is coming from a third-party seller on Amazon that appears to be a new seller without a lot of reviews based in China. And oftentimes when that happens, these are actually fake listings where you don't end up getting the part, you end up having to kind of refund it, and they got your money for a while for free, basically. I don't know exactly why they and how those scams work, but I wouldn't go with that. If we look at shipped and sold by Amazon, they're listed at $390 with currently $40 off coupon. I do say coupon, not coupon. You can deal with that. Take it up with the comment section if you'd like. Anyway, but $390 minus $40 is $350. So you can basically get the best gaming CPU on the market for $350. And like I said, even if you weren't scared of the Intel processors because maybe you have the new microcode or whatever, the top-end processors from Intel with the 14900K series is starting out at $536. So it's more expensive for generally slightly worse gaming performance, runs at significantly higher wattages, meaning to get the full performance you'll want, probably need to spend more money on a big cooler. And just in general, like I said, those stability issues are leading me to not really want to recommend them anyway. So from a gaming perspective, 7800X3D is absolutely still topping the charts, and yes, it is noticeably faster than the new 9000 series CPUs. And for those of you wondering, what about the 9000X3D chips? The latest rumors on this from the various leakers who have got things right in the past, so potentially have some inside information on it, and there are multiple of them kind of corroborating this, is that the Ryzen 9000 X3D parts won't launch until January, expecting a CES 2025 reveal. So if you wanted to wait until after January, potentially there will be better gaming CPUs on the market than the 7800 X3D. But you know, is it worth waiting that long? And also, are they even going to be that much better than the 7800 X3D? Because with the non-X3D parts, the 9000 series isn't much faster than the 7000 series. It's potentially the case that something better, you know, they did something additional with the X3D parts to make them a little more exciting. But anyway, it's potentially going to be not all that exciting, and it is definitely not available right now. And it doesn't look like it's coming out in September, which had been the original rumors. I wonder if AMD had originally planned a quicker launch with them, but then has maybe backed down on that a bit. Now, I will say that there are some rumors that apparently there could be a 7600 X3D part, which could potentially be a really good value and really strong performer for gaming, coming in September. But again, this is not official. This is a rumor from one source on Twitter. So this very much could not be true. Anyway, so I do want to throw that out there. Now, if you are waiting for newer CPUs coming out, we also will have Intel coming with their Intel Core Ultra 200 series, and apparently the rumor for them is that to be launching around October 17th. So if you are just able to wait, perhaps you could wait until October 17th and see if we get anything interesting coming from Intel, and at least a new generation would maybe potentially not have the stability issues to work, to worry about and things like that. But anyway, so best gaming CPU right now, 7800X 3D, but a lot of people aren't going to be wanting to spend $350 on a gaming CPU. Also, what about the people who are looking for productivity? So I do want to talk about that a little bit. So if you want a CPU that can do both productivity and gaming, if we look at the gaming tests, we can see that the the application tests, we can see these high core count processors are definitely much outperforming the 7800X 3D. It falls down to 68% of the performance of the 9950X, which is now topping the charts, right? But that doesn't mean the 9950X is the the CPU to buy. It definitely tops the charts, but you can see it's barely ahead of the 7950X. And also the 7950X3D, which does very well in both gaming and productivity workloads, is very near to the top of the chart here. Again, 7950X3D very near the top of the chart for gaming and very near the top of the chart for productivity workloads. So if you have a mixed use case workload, that 7950X3D right now is coming in at $450. So if it's still less expensive than that 14900K. It's only $100 more than the 7800X 3D. So if you need to do that mixed workload, that could be pretty interesting. And the 7950 non-X 3D is basically the same price. So if you have a mixed workload, I think for gaming and productivity, that 7950X 3D is going to get my recommendation at the top of the charts there. Okay, so what again, though, if we want to go to lower price points? Also, you have to think about, are you building a whole new platform or are you upgrading? Because I should mention that. So one thing that complicates recommending CPUs is that if you already have a gaming PC and you're looking to upgrade it, you have to think about what can drop into your motherboard and whether you're buying a whole new platform, because that can change things a little bit. So for example, a lot of people are going to be on, currently have a CPU like an AM4 that fits in an AM4 motherboard. And in an AM4 motherboard, you have a lot of interesting upgrade options that came out over the years. If you have a first gen Ryzen, second gen Ryzen, third gen Ryzen, there's a lot of interesting upgrade options. But if you're building a whole new platform, I don't think they often make sense once you already have to throw in the motherboard pricing and buying RAM and everything like that. You're not saving that much money. So first I'm going to start off with, okay, what if we're just buying a whole new platform? What would I recommend? And then we'll take a look at maybe for people who are upgrading off of an older platform. So I'm also going to switch over now to talking about gaming performance, because again, that is really what the channel mostly focuses on here. So if we're looking at gaming tests, this is where I said the lower core count parts are tending to now kind of overrepresent themselves in gaming compared to those heavily multi-threaded productivity workloads. So new chips like the Ryzen 5 9600X 6-core part are really near the top of the charts, but the problem on something like that is that a 9600X right now from AMD is coming in at $280. Again, you're not saving all that much money off something like the 7800X 3D, which is definitely a better gaming chip. And then also you can look at the previous generation parts. So that's really the issue with the 9000 series, is that the previous generation parts, like if we look down here to the 7600X, it's only a few percent slower, right? So the 7600X is only a few percent slower, but let's look at the actual pricing. If we look at the 7600, first of all, there's an X and a non-X version, and also let me make sure I'm typing in Ryzen so we don't look at the old Intel CPUs that are not what we're talking about right now. we can see that the Ryzen 5 7600 non-X is currently $182. The X version is only a couple of percent faster than the non-X version, and the non-X version actually comes with a box cooler, and it runs at a more energy-efficient power point. Which is really nice. It's coming in at $182. So if you look at this, at $182, there's the Ryzen 7600, and then if we make it a 9600X, we're going all the way up to $280. And I think you'll see why then when you look at the gaming charts, with the performance difference on these not being massive, I think it just makes way more sense to go with that Ryzen 5 7600. Now, some people might want to go with the 8-core part over the 6-core part, but again, when you actually look at gaming benchmarks, there's not that much of a gain in most games by going with the 8-core 16-thread part instead of the 6-core 12-thread part. So yeah, I mean, you could look at going with a 7700 or something like that if you really want those extra cores, but it is going to cost you an extra about $40 to do that, so may or may not be worth it to you. So I'm going to say somebody building a more value-oriented CPU, but you are putting together a new build on a new platform. I like the Ryzen 7600 right now. It comes with a box cooler if you really need to cut corners and get your budget down as low as possible. Or you could cool it with a very cheap, third-party cooler, $182, and you're getting very near the top of the gaming charts, right? It's not super far off these new chips. Yes, the 7800X 3D is faster, but it's not so much faster that it actually scales evenly from a value perspective. Now, this is where we could start thinking about, okay, what if you're upgrading on an older platform? Now, upgrading on an older platform probably mostly only makes sense for people on the AM4 platform, since AMD supported so many generations and had a huge amount of upgradability if you started early in that, compared to going onto a later generation. There was a ton of performance to be gained overall. For example, if we look at these gaming charts here, you can find like 2nd-gen Ryzen parts here, down at about 50% of the current gaming performance of something like our new 9950X, right? So that's a lot there. Now, the 9950X isn't compatible with the AM4 platform, but everything up to Ryzen 5000 series is. So if we look for the Ryzen 5000 series here, you can see parts like the 5800X 3D are still competing extremely well with our, fairly new chips here. And it's only slightly below, and it's basically tied with parts like the 7600X that I just recommended, 7700. The problem with the 5800X 3D is that availability on it is starting to kind of dry up. The 5800X 3D part, there we go, that's coming in at $390 new right now, so probably not the greatest idea. Now, the Tech Power Up review didn't show this particular chip, but there's a 5700X 3D, which is clocked slightly lower, but is within a few percent of that 5800X 3D, and this is coming in at about $210. Now, again, though, it's if you look at it compared to the part like the 7600 that I just recommended, which is less than $210, the performance here is going to be fairly similar in gaming when we look at these, right? So at fairly similar gaming performance, and the 5700X 3D is actually a bit more expensive. But if you're already on a Ryzen 1st-gen, 2nd-gen, 3rd-gen motherboard, odds are there's a BIOS update that would allow you to use the newer 5000 series chip with the same motherboard and the same RAM, and now you're actually saving a lot of money compared to building a whole new platform. So if you are looking into saving some money and not building a whole new platform, if you're still on an AM4 motherboard that would be compatible with this, and check that there's actually a BIOS update available for it and all of that, then something like a 5700X 3D starts to make sense. But it doesn't make sense for a new build compared to just getting something like a 7600. Now, if you are on a much older platform, like you need to go a lower budget than this. Maybe you're still on AM4, but you just can't afford that 5700X 3D. Going back to a part like a Ryzen 5 5600 and upgrading to that, it's about $117 right now. And if we look at the 5600, which I think they have some on the charts here, you're definitely falling down a bit in gaming performance. Notice the 5600 and 5600X, again, the non-X version just loses a couple percent. You're down here at about, 80% of the performance of, like our 9950X here. So near the top of the charts, you're losing about 20% performance. It's not a massive loss. And it could still be a pretty big upgrade from something like a Ryzen first gen or second gen chip. So you could take a look at that. Now, if you're building something completely new, though, like I said, I think trying to get on a newer platform with that 7600 can, I think, make a lot more sense. But also, if you're just trying to go with something super budget oriented, this could potentially just fit in your budget, and the newer platform doesn't, and so you could definitely take a look at that. Now, I do want to talk a little bit more about other options in this kind of lower end price point. Maybe you just can't afford those newer platforms. And what about Intel? It's really Intel's 13th and 14th gen chips that seem to be having a lot of those issues reported with the stability and degradation. So I will mention that parts like the 12400F from Intel are coming in at about $110. And if we actually look at the gaming performance numbers here for a 12400F compared to like that 5600 we were looking at, which would be slightly below this 5600X, the 12400 is actually in a similar ballpark and maybe a little bit faster, and is actually coming in at a little bit less money. So I will kind of give a shout out now that if we're down around the $100 price point, Intel does start to have some chips here that could make sense. So you could look at that 12400. Also, you could even go down to something like a 12100 if you're in a super budget oriented land, but at $85, you're losing a bunch of cores. I would really much rather try to hit that 12400 rather than go much below this. Now, at this point, I'm not going to recommend much below this. You certainly can go into super value-oriented builds and things like that, but I think it's going to be a bit beyond the scope of what I'm looking at in this video. So to kind of summarize the recommendations that I went with here, I would say if you want top-end gaming performance right now, and you don't want a headache with looking at compatibility, the 7800X3D, which isn't really $308 unless you really trust that random seller on Amazon based in China with not really any reviews, closer to $350. And again, you have to make sure you're getting compatible motherboard and RAM and all of that. That would be my recommendation. If you have a mixed productivity and gaming workload, I think the 7950X3D makes a lot of sense right now at $450. If you need a more value-oriented build, I think the Ryzen 7600 makes a lot of sense as an entry point at $182. And if you really just, I know some people just hate the idea of a 6-core part, then the Ryzen 7700 non-X at $219 also can make a lot of sense. But I think just from a strict bang for the buck perspective, the 7600 might be a slightly better deal there. But both of those could make sense. And if you have that extra bit in your budget, maybe go with the 7700. If you are already on an AM4 motherboard that has a BIOS update to allow compatibility, then for the ease of the upgrade, along with not having to buy a new motherboard and RAM and all that, then going with a 5700X3D at $210 can make sense as an upgrade if you're already on a compatible motherboard. And then again, in that upgrade, if you're already on a compatible motherboard, but maybe you're way down in the budget range, upgrading to a Ryzen 5 5600, as long as you're already on like a first or second gen Ryzen where this would be offering a pretty healthy performance boost, I think that could make sense. Again, if you're in this kind of price range, you could also look at something like an Intel Core i5 12400F, something like that at around $100. But if you're not already upgrading to that, if you're having to buy a motherboard and RAM and things like that, again, I would see if you could stretch your budget to get to a more modern platform like that Ryzen 7600. Yes, there's stuff available below the price points I've talked about in this video, but I think you maybe start to get kind of diminishing returns on what you're getting there, so I wouldn't want to go too much below this. Now, speaking of diminishing returns, I think I'm going to end this video just by reminding everybody that when you look at a CPU chart, performance chart like this, that doesn't mean that, let's say you upgrade from a Ryzen 5 3600 to a Ryzen 9 9950X, and the performance percentage scaling that you're seeing here, don't assume that's actually what will happen to you in your games when you're playing them, because that does also be a little bit of a complicated thing with CPU reviews and how to interpret them. Because in general, when you're playing a video game, your frame rate is either being limited by the CPU or the GPU, and a lot of times what people do is they adjust their graphics settings to a point where they're actually GPU limited. In other words, like, you might not see this full performance gain. It's just what could potentially be available. A really good way to think about CPU performance is that the CPU performance from your CPU and the way these reviews are performed is they're showing you like a maximum frame rate potential for your system before, like, turning down graphic settings won't really help you anymore, right? So a lot of times you're not, you'll end up actually GPU limited before you hit your CPU's limit, but the CPU performance is kind of like putting a maximum limit on how fast your system can go. But then, your GPU kind of works within that. So maybe your CPU can go this fast, your GPU can go this fast, then you're CPU limited, but you can turn down graphics settings to reduce the burden on the GPU, but a lot of times there's not a lot you can do for that CPU performance. It gets a little bit complicated, but I think the best way to think about it is your CPU performance in gaming is kind of limiting your maximum frame rate you can reach and how much you can adjust graphic settings and get a more powerful GPU to reach that point. Whereas the GPU often actually ends up being the limiting factor. So that's another thing to think about. Again, always think about if your motherboard's compatible, buying compatible parts with CPUs, because anyway, that's all stuff you got to think about. But hopefully you guys found this video useful and or interesting. Huge thank you to viewers, subscribers, commenters, and especially channel members who've clicked the join button down below to directly support the channel financially. That's absolutely huge. Huge thank you for those who did that. In return, you do get things like membership badges on your comments. They're easier for me to see, early access to certain content and all of that. So huge thank you, but totally understand that's not everybody's in a place to do that support financially, which is totally fine. Appreciate all of you. You are all beautiful people, and I hope you all have an excellent day.